Hello, this is meteorologist Ed Shimon, the instructor for Met 101 course. This particular chapter is going to be on monitoring the weather, your first chapter in this series, and it's going to cover just your basics of what you need to know about understanding weather and how we analyze the atmosphere and other types of monitoring systems that are out there. So the first basic question of the course, and that is, what are some characteristics of the atmosphere and weather? Understanding how weather develops and what portions of the atmosphere we actually are dealing with when we're talking about weather. Just starting off with a case in point here, referring to a blizzard back in 1888 that hit the northeast United States area, and it basically came without warning. They didn't have monitoring systems, observation platforms, satellites, or anything like that. So you had weather developing, that people just didn't know was coming, and there was a tremendous loss of life in that particular blizzard that hit the East Coast. There was 10 to 20 inches of snow and drifts up to 4 to 5 feet. People were caught off guard, didn't have the proper clothing. It was just a loss of life due to hypothermia in a large number of cases, and it's just kind of a tragic thing. And now, comparing that to 2009, 2010, we had 4 nor'easters hit the mid-Atlantic, and we had plenty of lead time and warnings. People took action to protect themselves because we knew it was coming. We have satellites, observation platforms all across the country, which really help us, and the computer models that show us exactly what we need to know in terms of where the heaviest snows are going to fall and who's going to be impacted the most. We have a much better understanding of the weather, and so it basically helps save lives. And you're going to get that basic understanding in this course of how the weather develops and progresses across the country, and how you can know what to do in case weather gets hazardous anywhere around you as well. So the basic weather definition is the state of the atmosphere at a place and time. That's the weather, and we quantify it with measurers: temperature, humidity, cloudiness, precipitation, wind speed, and wind direction. We take snapshots of the atmosphere at least once an hour and try and get a handle on what's occurring here and upstream, and what weather we may be seeing in the near future. Meteorology is the study of that whole process, the atmosphere, and the whole cycle of weather across the entire globe. So it's basically the science of weather. And if we go a little further, climate is basically recording of the weather, so to speak. And then we just average it over a period of time to give average conditions that you might see in the summer, winter, spring, or fall, depending on what season you're looking at. And we usually include a 30-year period, and then we'll bump that forward every time we finish a decade. So when we hit 2020, we're going to include the previous 30 years. When we get to 2030, we'll include the previous years. Then we'll just change about every 10 years. We change that 30-year cycle, just to see how the Earth is changing. Okay, now my normals have bumped up a little bit, or now my precipitation has gone down a little bit. We just analyze climate that way. Climatology is the study of climate, its controls and spatial and temporal variability. So it's like meteorology is study of weather, climatology is study of climate. Not too difficult there. Accessing weather information nowadays is so much easier with smartphones. You have information at the ready all day and night whenever you want it. The internet on general laptops and home computers, definitely a good way to stay informed as well. Sometimes smartphone viewing isn't quite as easy to see some of the weather information you might want to see, but with apps on those smartphones now, things are really packaged really nicely. Watching the television in the morning, maybe the Weather Channel, get a briefing of what's going on, or your local TV stations to see the weather segments of the morning news. Always important to planning your day as well.
NOAA Weather Radio, definitely a #1 way to get the immediate warnings out of the National Weather Service. And then when it's not in a warning mode, the broadcasts cycle every 4 to 6 minutes with weather information and climate information. But anytime a warning is issued, it'll immediately alarm, and especially at night, that's a really important thing for getting weather information. And then weather apps, as I mentioned earlier, are primarily the way the smartphones really provide that weather information to everybody. The time zones across the United States are there's 4 hours included across the United States, and then the Atlantic is just off the coast there. But time zones, timekeeping is the way that we can take observations and normalize them across the country as well. And we take our time zones based off of 0Z time being in England. The Greenwich Mean Time is midnight in England is 6 p.m. in central Illinois. So that's a 6-hour time difference under standard time. And then daylight savings time, we lose an hour or gain an hour, but the losing an hour takes us only a 5-hour difference. So midnight in England would be 7 p.m. in central Illinois. So, but the time zones are following the sun, basically. Noon local time is when the sun is directly overhead. So that's how the time zones are kind of basically set up. Whenever it's noon local, as close to that as possible, the sun will be overhead. So that's how timekeeping is set up, and that's how we use it for monitoring the weather. As I mentioned, UTC is based on an atomic clock. Actually, in Boulder, Colorado, there's a clock run by atomic motions, and it's exact pretty closely anyway to as we can get. And we express our UTC clock, Universal Time, as a 24-hour clock. So 7 a.m., 7:45 a.m. as you see is 07:45, just add a 0 in front. And then as you go through the rest of the day, anything past noon, you just, instead of going to 1, you go to 13. And as you see, 2:20 p.m., 14:20. And there's no daylight savings time in the universal clock, because you don't shift it up, forward, or back. It's always constant and moving forward. Surface observations, at least 4 times a day, but we usually, almost every observation site now is hourly, and then it takes more frequent observations if the weather changes rapidly. Upper air measurements, or balloon launches. We do those down in our weather office in Lincoln. And everywhere across the world, actually, it's 0Z and 12Z, or locally it's 6 p.m. and 6 a.m. And those provide valuable information to the weather models that we run every day, multiple times a day. So